All right, welcome back. So in this video, we're going to finish up section 8.5. In the previous video, we talked about probability distributions and creating histograms from those to be able to answer different questions. So here we're going to be looking at expected value of a random variable. So when we look at probability distributions, one of the things that we find very helpful for us is to have the concept of a typical or average value that a random variable takes on. So one way to approach this is by creating what's called an expected value based off that information. So when we look at an expected value of a random variable, we look at the idea that, let's say we have this random variable, and it takes on n values. And all these values are different parts of n. So we have x of 1, x of 2, x of 3, yada, 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 up to x of n. And let's say that each of these separate values has a probability that occurs, and we'll call those P1, P2, P3, Pn. So to calculate the expected value of a random variable, we refer to that as E of x, the expected value of x. And to calculate the expected value of x, we take each random variable value, x1, x2, x3, x4, yet, etc., 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 and we multiply it by the probability of that event occurring. Once we've done that, we take all these values and we add them together. So here it'd be x1 times p1 plus x2 times p2 plus x3 times p3 plus ... plus x of n times p of n, however many you have. Okay, so for example, we go back to broken monitors from the previous video. So they ask us to find the expected number of broken monitors that the shipping manager finds. So from the previous video, they wanted us to give the probability distribution for the number of broken monitors that the shipping manager finds, given that there are 3 broken monitors in a sample of 12. So here, to find that expected value, we would take the answers that we got from that previous example. So it would be 0 times 14/55 plus 1 times 28/55 plus 2 times 12/55 plus 3 times, oops, should be doing that down here. So the expected value of x would be our 0 times 14/55 plus our 1 times 28/55 plus 2 times 12/55 plus 3 times 1/55. So we end up with 0/55 plus 28/55 plus 24/55 plus 3/55, which gives us 55/55, which is equal to 1. So what does that tell us? Well, that tells us on average that the shipping manager will find 1 broken monitor in this sample of 4. That's what that tells us. Okay, so in our next example, this time, let's say the local sympathy decides to raise money by raffling an HD TV worth $400, a dinner for 2 worth $80, and 2 iTunes gift cards worth $20 each. A total of 2,000 raffle tickets are sold at $1 each. Find the expected payback for a person who buys 1 raffle ticket. Okay, so in this case, we have to look at the probability distribution. So I'm going to create a probability distribution of prize winnings. to help me answer this question. And I'm going to assign each of these a random variable. Okay? So we have our x, and we have our p of x, our probability. Well, how many prizes are there? Well, how many possibilities are there? Well, there are 4. Because if you think about it, x represents here how much that you would win based off of that, right? So the TV, it's worth $400. If I put $1 into it, I would expect a payback of $399. So if there's one raffle ticket drawn for a winner, the probability would be 1 out of 2,000. For the dinner for 2, worth $80. So if it's worth 80, I put $1 in to win it. The expected payback would be 80 minus 1, so it'd be $79. And again, one ticket, so 1 out of 2,000. So this represents the TV, this represents the dinner, this represents the iTunes gift cards, and then this represents nothing. Well, if I win an iTunes gift card, I put $1 in, so how much would I expect back? Well, I would expect $19 back. And because there's 2 of those, that would be 2 out of 2,000. Now, if I put $1 in, I don't win anything. How much money am I out? Well, I'm out $1, so we count that as -1. And what's the probability of me losing $1? Well, it'd be 1,996 out of 2,000. So, to find the expected value, E of x, we have to do 399 times 1 out of 2,000, 79 times 1 out of 2,000, 19 times 2 out of 2,000, and then -1 times 1996 out of 2,000. So when I do all this calculation, when everything is said and done, we end up with 399 out of 2,000 plus 79 out of 2,000 plus 38 out of 2,000 plus negative 1996 out of 2,000. Well, we end up with negative 1480 out of 2,000, which is approximately equal to negative 74 cents. So on average, for every raffle ticket that you buy in this raffle, the expected payback is going to be negative 74 cents. That's on average. Okay. So, next up. Now we look at a life insurance example. So, let's say that your insurance company at age 50 sends you a letter, and according to the letter, you have to tell the insurance company which option you would like to choose. You can either take $20,000 at age 60 if you're still alive, or you can take $30,000 at age 70. Again, considering if you are alive. Okay. So we know the probability of living from age 50 to age 60 is 0.88, and the probability of living from age 50 to age 70 is 0.64, based only on the idea of expected value. Which option should you choose? Okay. Well, so for option 1, to find the expected value, it's going to be 20,000 times the probability of you living to age 60, which is 0.88, plus 0 times 0.12. So when we do that calculation, we get $17,600. For option 2, this time it's $30,000 times the probability of you living to age 70, which is 0.64, plus 0 times the probability of 0.36. So you get 19,200. So based on this alone, option 2 is the best value. All right. So last but not least, if you're given a binomial probability, well, the expected value here is going to be the number of successes times the probability of success in each trial. Okay. So, for example, let's say that a family has 3 children. Find the expected number of girls in this family. Okay. So, if we have 3 children, the probability of a girl being born is 1/2. It's a 50-50 shot. It's either a girl or a boy. So to find the expected number of girls in this family, we would do our expected value n times p. So this would be 3 times 1/2, which is 1.5. So therefore, the expected number of girls in this family is 1.4. Okay. What if I chose 12? What if I have 12 children in the family? What's the expected number of girls? Well, this time we're going to use 12 as our n. So expected value would be n times p, so it'd be 12 times 1/2. So there would be 6. So on average, there would be 6 girls in this family. All right. So this brings us to the end of section 8.5. Again, as always, if you have any questions, please feel free to email me and we could set up a Google Meet to get together where we can go over more. Have a great day. We'll talk to you later.